and welcome back to JM Chemistry. Today I am going to show you a complete working model of water distillation that I built with my own hands using simple craft materials. If you are a student or you love science, this video is for you. By the end of this video, you will completely understand how distillation works and why it works. So let's get started. Before we look at the model, let me ask you a simple question. How do scientists get pure, clean water from dirty or contaminated water if water has salt dissolved in it? You cannot remove it with a simple filter. Dissolved salts pass right through. So what do? We use distillation. And distillation is one of the most important separation techniques in all of chemistry. Today you are going to see it working right in front of your eyes. Okay, so stage one, the heating unit. Look at the base of this model. We built this using color papers, cardboard, and glue. It holds the distillation flask in a stable position, so it does not move during the experiment. In a real laboratory, we use a Bunsen burner to provide heat. In our model, we have simulated this heating unit at the bottom of the setup. Remember this, distillation always begins with heat. Without heat, nothing happens. Now stage two, the distillation flask. Look at this central bottle. This is the heart of the entire model. This is where we pour the impure water that has dissolved salts, minerals, or contamination inside it. When we heat this flask, the water gets hotter and hotter, and when the temperature reaches 100 degrees Celsius, the boiling point water, the water turns into steam and rises upward. Now here's the most important point. The dissolved salts and impurities cannot evaporate. Their boiling points are hundreds of degrees higher than water. So the impurities stay behind in the flask, and only the pure water escapes as steam. This is the genius of distillation. Now stage three, my favorite part, the cooling system. We have steam rising up, but we cannot collect gas in the bottle. We need to turn that steam back into liquid water. This is what the condenser does. Look at this tubing. The steam travels from a flask through this pipe. We have connected a DC water pump here that pushes cold water through an outer jacket surrounding the pipe. So inside the pipe, hot steam is traveling. Outside the pipe, cold water is flowing around it. The steam loses its heat, cools down, and turns back into liquid water drop by drop. In chemistry, we call this condensation. And this tube is called a condenser. In real laboratories, it is called a Liebig condenser, named after the famous German chemist Justus von Liebig. Hot steam goes in, pure clean water comes out. Stage four, the wiring and pump system. We use a simple DC motor connected to a switch. When you flip this switch, the pump activates, and cold water starts circulating automatically. Now you might ask, why a pump? Because in distillation, the cooling must be continuous. If the condenser becomes warm even for a short time, the steam will not condense and will escape into the air. The pump keeps fresh cold water flowing nonstop, automatic, reliable. This is also an important engineering lesson. We automate the things that must stay constant. And now the final demonstration. Watch carefully. Impure water is in the flask. We apply heat. The water boils and becomes steam. The steam travels through the delivery tube into the condenser. Cold water flows around the condenser thanks to our DC pump. The steam cools down and turns back into liquid water, drop by drop, and collects right here in this beaker. Pure, clean, distilled water. No salts, no contamination, just clean water. This is a complete process of distillation, evaporation, condensation, and collection, all working together perfectly. Distillation is used everywhere in real life, in water treatment plants, in the petroleum industry, to separate petrol and diesel, in making perfumes, and in pharmaceutical factories to make medicines. So the next time you see distilled water, you know exactly how it was made. That is it for today on JM Chemistry. I hope you enjoyed this working model and learned something new. If you found this helpful, please give a big thumbs up, share it with your friends, and subscribe so you never miss a video. I will see you